So the equation on the right, square root of 12 minus 4w is equal to w. We can solve it using the same strategy that we solved the equation on the left, which means what? What did you do first? Square both sides. That has the effect of eliminating the square root right away, which is going to leave me with just 12 minus 4w on the left, and it's going to leave me with w squared on the right. And just like in the previous example, what did you do after that? Get everything on one side. Subtract the 12, add the 4w on the left and on the right. I'm going to take the liberty of changing the order of the terms over on the right just so that they're in the order that we're used to seeing them. So 0 equals w squared plus 4w minus 12. Okay, great. And then you factored? And how did this one factor?
W plus 6 and W minus 2.
W plus 6, W minus 2. Okay. And then the all-important step, not to be forgotten, split each one into its own equation. Yeah. We find out W equals negative 6 and W equals 2. And end of story. Right? I would make a terrible lawyer because I ask leading questions all the time. I suppose I'd make a good defense attorney, but not so much a prosecutor. Yeah, that's a leading question. End of story? No. Why not? What could we possibly have done wrong here? We used exactly the same procedure that we did in the example on the left. We got two answers, which also happened in the example on the left. I don't see a procedural error with what we did. All of our arithmetic was above board. You know, we squared the square root and it just went away. So we didn't commit an algebra error. So what reason do I possibly have to doubt that these are our solutions?
I just don't know why, though.
Okay, so we're popping a negative number out as a solution, and that's raising a red flag for Elizabeth. Right, so let's think about that for a minute. If in doubt about any solution to any equation ever in the universe, you can check it. Plug it back in to the original equation and verify that it works. If I were to plug 3 and 5 back into our equation over here for w, we would find that both of those numbers actually do give us solutions to the equation on the left. So let's try, in this equation, plugging in this suspicious negative 6 and seeing what happens. So if I do that, I'm going to work from the bottom up here. I'll get the square root of 12 minus 4 times negative 6. So negative 6 was our solution that we discovered here. And then on the right-hand side of the equation, we would write w again, which was negative 6. Okay. And then simplifying the quantity underneath the square root, 4 times negative 6 is going to give me negative 24. And 12 minus negative 24 is the same as 12 plus 24. That's 36. Whoops. So up here, what I end up with is the square root of 36. On the right-hand side of the equation, I have negative 6. What is the square root of 36, really? 6. Yeah. So, this is the reason to be suspicious about getting a negative answer in a problem like this, is that that negative answer has led us into, head-on, straight into a sign ambiguity, is what a mathematician might call it, where this solution makes one side of the equation equal to 6, but it makes the other side of the equation equal to negative 6. How come that happens? Why wasn't our usual process of solving this equation enough to help us avoid this trap? Because what this means is that we have to totally get rid of one of our solutions to this equation that we found, because it just isn't a solution. Why did that happen? Let me give you a hint. I think we can agree that 6 and negative 6 are different numbers. I'm just putting that out there, proposition on the table. Let's agree that 6 and negative 6 are different numbers. What about them is the same? Even though 6 and negative 6 are different numbers, they are an equal distance away from 0 on the number line, right? They're 6 units away from 0, which means, for example, that their absolute values are equal. After all, absolute value measures the distance of a number from 0. So those two numbers are the same distance away from 0. Is there anything that we did in the process of solving this equation that would lose that distinction? Is there any operation that we did to solve this equation which would take two numbers that are different but which are the same distance away from 0 and consider them after that operation to be the same? I would argue that it was the first thing we did. What happens in the equation 6 equals negative 6 if I square both sides? I get 36 in both cases. So that is the issue, right? Unlike the other operations that we've used in this course to solve equations up to this point, squaring both sides, or squaring in general, is an operation that mathematicians call not one-to-one. Or if you really want to be fancy, we call it not an injective operation. You don't need to use those words. But what it means is that we can give this operation two different numbers as input, and it spits out the same number as output. 6 and negative 6 are different, but they have the same square. So when we squared both sides, we lost that distinction between 6 and negative 6. It became unimportant, which is what allowed negative 6 to show up in the solution of our equation, even though if we roll the tape all the way back to the original equation, it doesn't work. This is the only thing that we've done in our course that will lead to this phenomenon that we call the phenomenon of extraneous solutions. Squaring and raising numbers to raising quantities to even powers is the only thing that we've done that breaks those rules. So how do you avoid falling into the trap of not catching an extraneous solution? Just do what we did. Check your answers. It is never more important to verify that your solutions to an equation work than it is when solving an equation involving a radical. If you're worried, and I promise there are multiple choice questions on our exam that test this very question. If you're worried about your solutions, verify them. Plug them back into the original equation and just check to make sure that both of the solutions that you got are actually going to make the original equation balance. Most of the time they do. But when radicals are at play, and when we raise both sides of an equation to an even integer power, it raises the possibility that something like this happens. So checking your answers always will make sure that you don't fall into this trap.